Okay, this is the question number 4. This is your graphical question. So part A, be careful, this is the graph of f prime. On what intervals is f increasing? So as soon as I see those words, I know I'm looking for where f prime is greater than 0. So this is the graph of f prime, so only from -3 to -2. It is a point for your justification, point for the interval. 2 points for part A. Okay, part B, find points of inflection of f. So I know points of inflection only occur where the second derivative of the function is 0 or undefined, and the sign changes. So let's look at where the slope of this graph would be the second derivative is 0 or undefined. So I see at -2, I see at 0, and I'm sorry, not at -2. I see at 0 the slope is undefined of this graph because it's a corner. I see at 2 there's a slope of 0 because I have a horizontal tangent. Now let's just make sure the sign is changing. So at x equals 0, the slope of f prime does change. So I would say f prime changes from decreasing to increasing. Or you can say slope of f prime changes from negative to positive, and then x equals 2, f prime changes from increasing to decreasing. Or again, you can say slope of f prime changes from positive to negative. As long as the justification refers to f prime, it is 1 point for each answer with the justification that goes with each. 2 points part B. Okay, part C. Find an equation for the tangent line. So they give me a point already. The only other thing I need is the slope at that point. The slope at 0, just pick it out from the curve, is -2. My equation is y minus 3 equals -2 quantity x minus 0. 1 point for the entire equation. Part D, find f of 3 and f of 4. Okay. In order to find f of -3, you should be thinking, I need to integrate f prime, and I will use -3 as one of my bounds. The only other point that you have information about is this point 0, 3. So I'm going to use that other bound 0. So I know if I integrate f prime from -3 to 0, this is f of 0, upper bound minus the lower bound. So this is an important piece of the setup. Okay, what I'm looking for is f of -3. Okay, f of 0 is given. We know that is 3. This entire integral, I will need to find that area geometrically. So if I want to find the area or the integral of f prime from -3 to 0, it is this area all the way to here. So basically what you're going to do is find the area of this triangle, and I believe the area of this little triangle is 1/2. And then I believe the area of this little triangle is -2, but because it's below the x-axis, I want to count it as -2. So the integral from -3 to 0 is actually -1.5. So this value is -1.5 is equal to 3 minus f of -3, and then you can solve this in an equation, so f of -3 is really positive 4.5. Okay, they're looking for, can you calculate this -1.5 correctly, and do you understand that you have to add that initial condition? So there's 2 points, but there's multiple ways you can get here. Okay, I'm going to do the same thing for 4. I'm going to use 0 and 4. So this is f of 4 minus f of 0. Again, f of 0 is given. I know this is 3. I need to find f of 4. This, I'm going to, again, go to my graph and do it geometrically. So if I look from 0 to 4, what I'm looking for is this here. I'm going to color it in orange. This. But notice, in order to get that, what you're going to need to do is find the area of this rectangle, which is 8, and you're going to subtract off the area of this half circle, which is actually 2 pi. But because this region is below the x-axis, I have to count it as a negative for the integral. So this is that value right there. So if I plug that in, -8 minus 2 pi, and if you solve for f of 4, you will get -5 plus 2 pi. Again, they're looking for, can you calculate this piece correctly? Do you understand? You have to use that f of 0. Again, 2 points for this value, but multiple ways to get there.